The first law we will discuss is Gay-Lussac's law, which was created by the French chemist Joseph Gay-Lussac. In his law, he states for a given amount of gas held at constant volume, the pressure is proportional to the absolute temperature. The mathematical formula is represented by P1 divided by T1 equals P2 divided by T2, where P1 and T1 are the starting pressure and temperature respectively, and P2 and T2 are the ending pressure and temperature respectively.
So today we're going to explain Gay-Lussac's law by crushing a metal can. First, we're going to want to get a bowl. Next, make sure the water gets decently cold. Fill it up. Now we want to fill it up to the top because when we flip the can, we just want it to hit the surface of the water, or else it won't work.
And Gay-Lussac's law explains that as temperature increases, pressure will also decrease. So they're directly proportional to each other. And the two components that remain constant are the volume and the number of moles. So as you see, Nick is placing the bowl down and he's going to turn on the stove to get the can heated. And he's going to use tongs to transfer the hot can into the water.
First, we have to put a little bit of water in the can. Nice. Now, as Joe's going to demonstrate, we're going to get some ice. And now Joe can put the ice in to the bowl. Trying not to splash it. As we can see, the can is starting to steam, so this ice should start to hurry up a little bit. Once the ice is in and the can is steaming, we're going to want to grab the can and quickly put it onto the surface of the water. As we see, once the can that was hot hits the surface of the ice-cold water, the pressure drastically decreases as the temperature decreases, therefore crushing the can. So that is a demonstration of Gay-Lussac's law.
The second law we will discuss is Charles' law. Charles' law was created by Jacques-Alexandre César Charles, a French scientist. In his law, he stated that at a fixed pressure and amount, the volume of a gas is directly proportional to the temperature of the gas. This means that as temperature increases, so too does the volume, and as the temperature decreases, so too does the volume. The formula of Charles' law is V1 divided by T1 equals V2 divided by T2, where V1 and T1 are the starting volume and temperature respectively, and V2 and T2 are the ending volume and temperature respectively.
Now we will discuss Charles' law. While I blow up this balloon, Joe will explain what Charles' law is.
Charles' law explains that temperature and volume are directly proportional to each other, which means that as temperature increases, volume will also increase, and as temperature decreases, volume will also decrease.
Once the balloon is filled up, we will tie it off and take the circumference
with the tape measure.
So, this filled up the balloon. Measures 25 inches. So, 24.5 inches.
And now we're going to place it into
ice cold water.
a bucket of ice water. Then we're going to place it into the freezer. Now, if our experiment works, when we take it out of the freezer in 15 minutes, the balloon circumference will decrease.
See you then. And we're back here to check out our Charles' Law experiment. So let's take a look in the freezer and check out our balloon that has been sitting in ice cold water for the past 18 minutes. Now, to check the circumference.
Now remember, the circumference before when we took it was 24.5.
So,
A little bit more, closer to 25. So let's see what it is now.
as we can see, our circumference is about a tad past 20. Oh wait, a tad before 23 inches. So, as we can see, this balloon has lost a little more than an inch in circumference due to the change in temperature.
So this proves the point that as temperature decreases, the volume will also decrease, as Charles explained in his law.
So, now we can put our balloon back in the freezer and let it waste away to a deflated balloon. Until next time, this was Nick and
Joe
with your daily experiments.
The third law we'll discuss is Boyle's law. Boyle's law shows the relationship between pressure and volume. Boyle's law is an inverse relationship. That means that as volume increases, pressure will decrease, and as volume decreases, pressure will increase. Now let's go see the experiment. So Nick will perform the experiment.
So here we have a 2-liter bottle filled with water. And here we just have a simple medicine dropper with a rubber stopper. The rubber stopper is basically to keep the gas inside confined, as these are all confined gas laws. So, once we put the rubber stopper in, we notice that it floats right at the top. Now we're going to seal it so that there's more confined gas inside the bottle. As we squeeze, generating pressure, the volume decreases inside the medicine dropper, therefore causing it to sink. And as we release the pressure, it floats back up to the top. So let's see that again. And when we release, so that's a demonstration of Boyle's law. Welcome back. Today we're going to describe Avogadro's law. So Avogadro's law is a relationship between volume and number of moles. As the volume increases, the number of moles also increase, and it's a direct relationship. So as we're going to see, we're going to do a balloon experiment. While Joe blows up this balloon, he's adding more moles into the balloon, therefore increasing the volume. So, as you can see, he's putting more carbon dioxide gas into the balloon, therefore increasing the number of moles. As you can see, as he keeps blowing, increasing the number of moles, the balloon expands, and the volume inside is rising. Now, if he sucks in, the volume is going to decrease, because he's taking out the number of moles. As you can see, as the moles are released, the volume decreases slowly. So that's Avogadro's law.
So the final law we're going to discuss is the combined gas law. This law combines Boyle's law, Charles' law, and Gay-Lussac's law. The components of the experiment are a candle, which will be lighted in a few seconds, some silly putty, some water, and a glass, which will go over the candle. Now I'll turn it over to Nick to explain what's going to happen.
So basically, once we light the match, all of the oxygen inside the glass will be sucked up by the candle. Once that happens, it's going to create a mini vacuum. And that mini vacuum is basically going to suck all the water from the outside of the glass up into the glass once the candle burns out.
As you see the candle shortly.
As you can see, the water is moving up into the glass, filling up the glass. So that is a demonstration of the combined gas law.